Hey, and welcome. Today, we're going to pull back the curtain on one of the most powerful technologies out there, machine learning. We're going to break down how computers go from just, following orders to actually learning and making predictions all on their own.
I mean, just think about it for a second. When you're online, doesn't it feel like the internet just gets you? Like it knows what you want, sometimes even before you do? So, how on earth does that happen? Well, it's not magic, it is all machine learning.
Every single time you search for something, a machine learning algorithm does what no human ever could. It sifts through billions upon billions of pages in a fraction of a second. It's learned from the content, the links, and what millions of other people have clicked on to predict the one perfect result just for you. And it's the exact same idea with your favorite shopping sites or streaming services. They use this really clever technique called collaborative filtering. And what's wild is that the system doesn't need to know what a movie is about. It just knows that other people who have tastes like yours also happen to love this other thing. It's using that wisdom of the crowd to make a pretty good guess about what you'll want to watch next. So to really get how this all works, let's zoom in on a problem we all know and, let's be honest, we all hate: junk email. Filtering spam is a perfect, and I mean perfect, example of a machine learning task, mainly because the spammers are always changing their tactics. Right. You can't just make a simple rule like block all emails with this one specific word, because the spammers are just going to misspell it or come up with a whole new scam tomorrow. You need a system that can actually learn and adapt to these new patterns as they pop up. So here's the game plan. We want to teach a computer to look at any new email that comes in and make one simple decision. Is this piece of junk, which we call spam, or is it a real message that you actually want to read, which we call ham? Okay, so let's get into the nitty-gritty. How can a machine possibly read an email and decide if it's spam? Well, the very first step is to translate those words into the only language a computer really understands: numbers. The simplest way to do this is a model called bag of words. Literally, imagine taking all the words from an email, tossing them into a big bag, and then just counting how many times each word appears. Now, you lose all the grammar and sentence structure, sure, but what you gain is a simple numerical fingerprint of that message. And this table here, this is what it actually looks like in practice. We're turning language into a list of numbers, what's called a vector. The computer doesn't see the word fox, it just sees a 1 in a specific column. This simple transformation is what lets us start doing math on regular text. Okay, so this is where the real learning happens. We feed the machine thousands of emails that we've already labeled as spam or ham. It just counts the words in both piles and learns that, for example, the word free shows up way more often in spam. So when a new email comes in, it adds up the scores for all its words, and if that total score crosses a certain line, boom, it's sent to the junk folder. And that right there has a name. This incredibly powerful technique is called Bayesian spam filtering. It's named after Bayes' theorem, which is just a fancy way of saying you should update your beliefs when you get new evidence. Here, the evidence is the words in the email, and the system is constantly updating its belief about whether that email is spam. So we figured out spam, but here is the truly amazing part. This core idea, turning information into numbers and then finding the patterns, it goes so much further than just sorting your inbox. The same basic principles can be applied to a massive range of problems. Remember how we turned words into a vector, a list of numbers? Well, you can do that with almost any kind of data. We can analyze a patient's medical stats, the grid of movie ratings on a website, the individual pixels in a photo, or even the super complex web of connections in a social network. What our spam filter was doing is a classic machine learning task called classification. For us, it was a simple choice between two buckets, spam or ham. But you can easily expand this to choose between hundreds of categories, like identifying a flower from a picture or figuring out if a news article is about sports or politics. But what if you don't want a label? What if you want to predict an actual number? Well, that's called regression. Instead of asking spam or ham, you're asking how much or how many. This is used for everything from trying to predict stock prices to monitoring an athlete's performance in real time.
And then there's one of my personal favorites, finding the odd one out. This is called novelty detection. It's all about teaching a machine what normal looks like, so it can immediately flag when something is, well, weird. This could be a fraudulent credit card charge, a tiny flaw in a jet engine, or just a really sloppily written number on a piece of mail?
All right, we have covered a lot of ground here, from spam filters to stock prices and beyond. So after all that, what's the big picture? What's the one thing you really should take away from all of this? At its heart, machine learning is just this. It's a toolbox for finding meaningful patterns in data and then using those patterns to make really good guesses about new things it hasn't seen before. It's not a machine thinking like a person. It's a machine being incredibly good at finding statistical clues, just on a massive, massive scale. And that brings us to a final, really critical question to think about. We've established that these systems learn from the data we give them. So if the data we use to train them reflects the world's existing patterns, including our own flaws and prejudices, what's to stop the machine from learning those too? It's a huge challenge, and something we all need to be thinking about as this technology becomes more and more a part of our lives.